Welcome everyone, this is engineering tutorials, and today we are going to work on head losses and centrifugal pumps. We're going to first get the formula, prove how we get the formula for head losses. First, and then we're going to do a similar equation involving head losses in centrifugal pumps. First thing you need to know that Q discharge is equals to area times velocity, final velocity, but Q is equals to D times B, which is depth times breadth for area times final velocity, but B is equal to D if the for small lengths B is equals to D. So we can also say that Q is equals to D squared times final velocity, but U is equals to pi dn over 60, which is directly proportional to n if pi is small. If the pi is small, or if the cross-sectional area of the pipe is small. So, but also U is directly proportional to final velocity, is also directly proportional to the square root of maximum head. So square root of maximum head loss is directly proportional to dn, which is diameter times rotational speed, but d is equals to square root of head loss over rotational speed. So hm over n squared times final velocity is directly proportional to hm over n2 times square root of hm, which is also directly proportional to square root of hm raised to power 3 over 2 over n2. So Q is equals to K square root of hm 3 over 2 over n over 2. K is a constant, hm is equals to 1, Q is equals to 1 meters squared, and n becomes ns. After equating, you get that 1 is equals to K, 1 raised to power 3 over 2 over n squared s. K is equals to n squared s. Q is equals to n squared s. hm 3 over 2 over n squared, or n squared s is equals to n squared q over hm 3 over 2. After evaluating all that, you get that ns is equals to n square root of q over hm 3 over 4. I'll further use this equation to do a question involving centrifugal pumps. And centrifugal pipe delivers 0.5 meters cubed of water against a head of 12.5. The speed of the impeller is 600 revs per minute. Outer and inner diameter are 500 millimeter and 300 millimeters. Vents bent back to back at 35 degrees to tangential exit if the area is 0.07 meters squared. Calculate the hm. Q is equals to area times Vf. So to get Vf is equals to Q over A, which is 0.05 over 0.07. You get that it's 2.14 meters squared. Tangential velocity of the inlet and outlet. So u1 is equals to pi dn over 60. After evaluating pi dn of 1, you get that pi times 0.5 times 600 over 60, you get it 15.7 meters per second. u2 velocity 2, you get that it's 7.85 meters per second. Outer velocity, which is vf2, is equals to u2 minus vf1 over tan theta. That is 15.7 meters per second, which was the final velocity, minus 2.14. Somewhere we were told that it was 2.14 vf, final velocity 2.14 over tan 35, which was the tangential exit. You get that vf2 is equals to 12.6 meters per second. So to get the thermometer efficiency is equals to gravity times hm over vw2 times u2. So vw2 you have already gotten, which is 12.64 meters per second, and u2 is 15.7 meters per second. So it is 9.18 times 12.5 over 12.64 times 15. Get that it is 61.8%. I hope you have understood. Make sure to kindly follow the procedure, and then we'll be able to work on this example. Work on this example, try several times, and you'll finally get that you're able to do some question involved in this. Next time I'll come up with more complex examples that are going to teach you how to work on the same. But make sure you subscribe for channel and hit the notification bell for new videos that are informative like this.